So, well, I think the problem mostly is not very hard. It gives you the graph of the function which they want you to find absolute maximum minimum and local maximum minimum. So there's one thing I want to clarify. If you go over the definition of a local min, local max, it says the point at the local min, local max, the function value must be greater than or equal to. That's the important part. It could be equal to then everything next to it in the neighborhood, right? X is any X near A. That's the definition. So when you talk about being locally maximum or locally minimal, it could be identical to the value of its neighbor, but still being called a local minimum or local maximum. It doesn't have to be strictly greater than what you have. In other words, if you have a class of students, 5 of them, everybody get 100 points, then you can call every single one of them to get the local maximum grade or local minimum grades, right? It's okay to be identical to the rest as long as you don't have anything that's even larger, then you can call it a local maximum. So that is to say the point B, C, D, and R, they are all going to be called local minimum. I think those are quite obvious. At least this one is quite obvious that it's a minimum, but I want to point out those points, even though they are not necessarily having a value less than its neighbor, but they have values less than the neighbor, but also equal to its neighbor, right? Equal to its neighbor, equal to its neighbor, equal to its neighbor, less than its neighbor. So they are all local minimum. I hope it would help you to find the local maximum point as well along the same line of thinking, right? So this is a local maximum. This is a local maximum. This one is also a local maximum because you don't have any larger value in its neighbor, even though you have the same value repeatedly appearing. So those are the 3 local maximum point. So hopefully I clarifies the definition a little bit for you, right? And even though this and that are somehow extreme values, but they are not local because they don't have a neighbor on the other side. So those two cannot be called local minimum nor local maximum, right? So hopefully this helps.